Good morning to all. In the last class, we have learned about quadratic equations. Now, again, quadratic equations, we have learned how to find the solution of a quadratic equation by factorization and by using quadratic formula. And again, what are the conditions for consistency, etc. So that chapter was over. Now I'm going to start with arithmetic progression. Now again, in the case of arithmetic progression, in the new revised syllabus it is written, motivate the students to study the derivation of formula for finding nth term of an AP and sum of n terms of an AP. It's not clear. It is written motivate the students. Maybe there, may not be there. But again, the number of periods allotted for arithmetic progression is 4. That means this chapter is there in the syllabus, maybe with less weightage. But if we try to do only few questions, there can be confusion. So what we are going to do, we'll do in detail, but we won't cover each and every question. Today I'll give you an introduction to arithmetic progression. Then next class we will derive the formula for finding nth term of an AP, and again we'll do few questions. The next class we will do sum of n terms of an AP and we'll solve few questions. So like that I'm planning. So what is an arithmetic progression, or we'll write in short AP, arithmetic progression. So what is an AP? To understand what is an AP, first of all you have to understand a sequence of numbers. Now sequence of numbers is a set of numbers which are linked to one another by a rule. There is some common rule is there, or you can define the set of numbers, then it is called a sequence of numbers. Say for example 1, 2, 3, 4, etc. This is a sequence of numbers. Then 2, 4, 6, 8, etc. Or 5, 10, 15, 20, etc. Again, say 1, 4, 9, 16, etc. Again 1, 8, 27, etc. Or 1, 2, 4, 8, 16, etc. These are all sequence of numbers. See, for what is first one? 1, 2, 3, 4 counting numbers. It is well defined. Then even numbers. Then multiples of 5. Like that, there is a common relationship. These are all multiples. The multiples of 5 is going on. Again, these are squares of first few natural numbers. Square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, and so on. Then 1, 8, 27, etc. Cubes of numbers. Cube of 1, 1, cube of 2, 8, cube of 3, 27. What is the next one? 64. That is cube of 4, etc. So it is going on. Now what is the relationship in this one? See, 1, 2, 4, 8, 16. So 1 into 2 is 2. 2 into 2 is 4. 4 into 2 is 8. 8 2s are 16. So here in this case, each term is multiplied by 2 to get the next term. So like this, these are all sequence of numbers. Now, what out of these which are arithmetic progression? See, the first 3 are arithmetic progression. Now, the definition of arithmetic progression, arithmetic progression is a sequence of numbers in which each term except the first term is obtained by adding a fixed number to the preceding term. A set of numbers or a sequence of numbers in which each term except the first term, because there is no term before that. So except the first term, all the terms are obtained by adding a fixed number to the preceding term, the term before. When a fixed number is added, we get the next one. Again, that fixed number is added, we'll get the next one, like that. Let us check. See, 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. So, what is a fixed number? That is 1. So, in this case, when 1 is added to each term, except the first term, for every term is obtained by adding 1 to the preceding term. When 1 is added to this, we get this. Again, when 1 is added, we get this. When 1 is added, so see the second one, 2, 4, 6, 8, etc. Now 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. And 10, 12, 14, etc. So 2 is added to each term except the each term to get the next term. But in the case of first term, see, a sequence of numbers in which each term except the first term is obtained by adding a fixed number. So in this case, that fixed number is 2. Now third one, 5, 10, 15, 20, etc. Again it is an AP because 5 is added. 5 plus 5, 10, 10 plus 5, 15, 15 plus 5, 20, etc. So these first three are examples for arithmetic progression. Now, just for your understanding only, out of these, one is geometric progression. Now, if you are taking mathematics in higher classes, you will learn about geometric progression also. Otherwise also, when you read newspaper and all, say for example, this COVID-19 is spreading geometrically, we can say. Means, see what is geometric progression. See, the last one is an example for geometric progression. Here in this case, each term except the first term is obtained by multiplying a fixed number. See, 1 into 2, 2. 2 2s are 4. 4 2s are 8. 8 2s are 16. So like this. See, 1 into 5, 5. 5 5s are 25. Again 25 into 5, 125. Like that, if the sequence is going, it is called geometric progression. So, forget about geometric progression. We are learning about arithmetic progression only. What is an arithmetic? First of all, a sequence of numbers. It is a set of numbers which are linked to one another by a rule. Means there should be a definition. If I write just few numbers, say 1, 3, 4, 2, 9 and all, they are not an arithmetic progression or sequence of numbers even. But here in this case, it is a sequence of numbers because there is some definition is there. You can define this and or you can find out the next number using that link. Now, in the first three cases, when one fixed number is added to each term, we get the next term. Such sequence of numbers are called arithmetic progression. I'll tell you the definition once again. Learn the definition. It is a sequence of numbers or a set of numbers or a list of numbers in which each term except the first term is obtained by adding a fixed number to the preceding term. Term just before. Preceding term is called an arithmetic progression. So, it is a set of numbers in which each term except the first term is obtained by adding a fixed number to the preceding term. So, now the first term in these cases is first term is 1, 2, 5, etc. Now, the fixed number which is added is also called common difference and it is represented by using D. See, there are some symbols used in arithmetic progression. First one is small a for first term. This is for first term. first term, then D common difference or the fixed number which is added, then an is nth term, this will learn later, then Sn is sum of n terms. Then last one L, it is same as An only, that is last term. Sometimes last term is represented by using L also. So these last three will learn when we derive the formula. See, A is the first term is denoted by A, then common difference, that is the fixed number. In the definition we said when a fixed number is added we get the next term, that number is called common difference. And again nth term, say fourth term, we'll write A4, fifth term we will write A5. So n can take any value. Now Sn, sum of, say the sequence is 2, 4, 6, 8, 10, etc. Now this is an arithmetic progression because when 2 is added we get the next term. So it is first you have to check whether it is an arithmetic progression or not. It is an AP. Now what is S4? S4 means sum of first 4 terms. 8 plus 6, 14, 14 plus 4, 18 plus 2, 20. So 20 is S4. So Sn is sum of first n terms. And L is the, suppose the arithmetic progression is ending somewhere, then the last term is represented by using letter, small letter. So like this. So at least for the time being you learn what is A is the first term and D is the common difference. So what is the general form of an arithmetic progression? General form. See, first term is A, then when D is added we get the second term. So second term is A plus D. Again when D is added we'll get the third term. So A plus D plus D. A plus 2D is the third term. Again when D is added, A plus 3D, etc. it will go on. So this is the general form of an arithmetic progression where A is the first term and D is the common difference. So you should know the definition of arithmetic progression. You should be able to check whether the given sequence of numbers is an AP or not. So in the book, first exercise is just to make the concept clear. They are given all type of questions. So first they are given some examples and you have to check whether the sequence of numbers is an arithmetic progression or not. Second one, again if an AP is given, you should be able to identify what is A and what is the value of D. Then third one, if A and D are given, you should be able to write the AP or arithmetic progression. Then last one, if a sequence of numbers is given, you have to check whether it is an AP or not. So we'll discuss few questions from the book now. See, you can also take out the book, exercise 5.1 only. I am not going to do each and every question. Simple questions I am not doing, direct only, and later if you have problem you can say. See, because we are not sure about what is coming and what is not. So in which of the following situations, this is just for understanding what is an AP and how to do questions based on AP and all. See, the first question says, question is, in which of the following situations does the list of numbers involved make an arithmetic progression and why? Now they are given some cases, situations, and you have to study the numbers involved and then you have to check whether it is an AP or not. Say for example, first one, actually it is oral question only, one or two questions there can be confusion, so let us go in detail. Now first question is simple. The taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. First kilometer it is rupees 15 and thereafter for each kilometer rupees 8. So if a person is traveling 1 kilometer, how much he has to pay? 15. Then if 2 kilometer, second kilometer he has to pay 8 rupees each. 15 plus 8, 23. Then 23 plus 8, 31. Again 39, etc. See, they are saying for the first kilometer it is 15 rupees and thereafter each kilometer it is rupees 8. Now check whether number involved is an AP or not. So first kilometer 15, after 2 kilometer 15 plus 8, 23. Then after one more kilometer 23 plus 8, 31. Then after one more kilometer 31 plus 8, 39, and it will go on. So it is an AP. Now see 23 minus 15. How will you check whether it is an AP or not? What is the condition? Whether fixed number is added and obtain the next term or not. So 23 minus 15, 8, 31 minus 23, again 8, 39 minus 31, again 8. So like this only we'll check whether the given sequence of numbers is an AP or not. Now second question, understand carefully. See, the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. See this question, there can be confusion. See, question says the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. And you have to form this sequence of numbers and you have to check whether it is an AP or not. So first full it is. Then each case 1/4 of the air is removed from the cylinder. So after some time, see, 1 minus 1 upon 4, 1/4 is removed, LCM 4, 4 minus 1, so 3 upon 4 is left. So 3 upon 4. Now again 1/4 of this is removed. See, 3 upon 4 is already there, minus 1/4 of 3 upon 4. I am directly changing into multiplication. See, they are saying in each case whatever is the air left inside the cylinder, 1/4 is removed. Whatever is left. Now how much air is there? 1/4 is removed, 3/4 is there. Now 1/4 of 3/4 will be removed. So 3 upon 4 minus 3 upon 16, LCM 16, 4 4s are 16, 4 3s are 12, minus 3, which is equal to 9 upon 16. So 9 upon 16. Again, whatever is the air, now the air present in the cylinder is 9 upon 16 by volume. Now the 1/4 of this is removed. So 9 upon 16 minus 1 upon 4 of 9 upon 16. That is 9 upon 16 minus 9 upon 64. LCM 64. 16 4s are 64. 9 4s are 36 minus 9, which is equal to 27 by 64. So 27 upon 64. Now this is going on. Now you have to check whether it is an arithmetic progression or not. We'll subtract these two and these two. If we get the same answer, we will write yes, it is an AP. Otherwise we'll write no, it is not an AP. See, 3 upon 4 minus 1, LCM 4, 3 minus 4, is equal to minus 1. So we are, when we subtract this one, we are getting minus 1 upon 4 we are getting. Now we'll do one more and check if we get the same answer. See, 9 upon 16 minus 3 upon 4. LCM 16, 9 minus 4 4s are 16, 4 3s are 12 minus 3 upon 16. In one case we are getting D minus 1 upon 4. Here we are getting minus 3 upon 16. So it is not an AP. See, understand carefully. Question says, I'll read the question once again. Question says, the amount of air present in a cylinder when a vacuum pump removes 1/4 of air remaining in the cylinder at a time. So initially it is full, we assume, then 1/4 is removed, that means 3/4 is left, again 1/4 is removed, we'll subtract and find out another 1/4 is removed again. So whatever is air left, we'll make a sequence of numbers and we'll check whether it is the difference between second term and first term, third term and second term, etc. same. If they are same, we'll write yes, it is an AP. If they are different, then we'll write no, it is not an AP. It can be negative, positive, 0 and all, no problem. Only condition is answer should be same. Then we'll write it is an AP. Now third question. The cost of digging a well after every meter of digging, when it costs rupees 150 for the first meter and rises by rupees 50 for each subsequent meter. So direct question only. 150 for first meter and rupees 50 for each. So 150 for the first one, then first meter, then after 2 meters 50 more. So 200, then 250, then 300, etc. It is going on. So it is an AP only because 200 minus 150, 50, 250 minus 200, again 50 and so on. So it is an arithmetic progression. Now the fourth part, the amount of money in an account every year when rupees 10,000 is deposited at compound interest at 8% per annum. Now you have learned in class 8th what is compound interest and simple interest. What is the difference? In the case of simple interest, the principal will remain the same. Suppose you are depositing money for 5 years. Throughout 5 years, your principal will remain the same. Say for example, I am depositing 10,000 at simple interest. First year, second year, third year, fourth year, fifth year, all the throughout 5 years, my principal will remain 10,000 only. But in the case of compound interest, if it is compounded annually, after every year, interest will be calculated and added to the principal. So for example, 8% is the rate of interest. So first year I will be getting rupees 800 as interest. Oral calculation only. 800 I will be getting. Then next year, second year, my principal will be 10,800. Again I will get 8% interest and it will go on. So definitely, since the principal is changing, the amount at the end of each year will be different and it will not be an arithmetic progression. Or we can do calculation and show. You can find out the amount at the end of 2-3 years and then you can show that they are not in arithmetic progression. Actually, you can write directly if you are clear with compound interest. Because the principal is changing, so the amount at the bank also will be, see, A is equal to P into 1 plus, or we'll use simple interest. This will be, calculation may be long, we'll use simple interest only. So interest for first year. How much money is there? 10,000 into 1 year into 8 upon 100. P into T into R upon 100. So these two zeros cancel, we'll get 800. Then P4, or amount at the end of 1 year, will be 10,800 rupees, because I deposited 10,000 rupees, 800 rupees as I got as interest, so 10,800 is there. I am not writing the unit and all. Now interest for second year is equal to, again, P into T into R upon 100. How much money in the bank? 10,800 into time, 1 year only, and rate of interest again 8 upon 100. So 0 0 cancel. Then 8 8s are 64, 6 8 8s are 64, 6 864 rupees is there. This is the interest for the second year. So at the end of second year, this 10,800 was there, and I got 864 as interest. So total amount at the end of second year is equal to 10,800 plus 864, which is equal to 10,800 plus 864, 11 is equal to 11664. See, this much is at the end of second year. Now we'll do calculation interest for the third year. Interest for third year is equal to, again, P into T into R upon 100, 11664 into 1 into 8 upon 100. Multiply, 8 4s are 32, 3, 6 8s are 48 plus 3, 51, 5, 8 6 are 48 plus 5, 53, 5, 8 4s are 32, 3, 8 6 are 48 plus 3, 51, 5, 1, 3. I'll do the multiplication. If I try to 11664 into 8, 93312 upon 100, which is equal to 933.12 rupees. So amount at the end of 3 years, how much it was? 11,664 plus 933.12, 0.00, add 2179521. So this much money is there. Now see the amount in the beginning, after 1 year, amount at the end of, see, let us write the sequence now. Question is amount in the bank at the end of each year. First year it was 10,800. Then after 2 years, it was 11664. Then after third year, 12597.12, etc. Now if you subtract this one, you will get 864, but if you subtract this one, you will get a different number. So it is not an arithmetic progression. So actually you don't need to do calculate, you can write directly if you are clear with compound interest, because compound interest says this only. See, interest is calculated after a particular period of time and it is added to the principal. So interest will be calculated and added to the principal. So after 1 year, so principal is going on changing. So naturally the amount in the bank at the end of every year will not be increasing in a proportional rate. But if the question is in simple interest instead of compound interest, simple interest, then it is an arithmetic progression, because every year 800 rupees will be added. But here in this case, first year 800 is added, second year 864 is added, third year 933.12 is added. So different amount. So it is not an arithmetic progression. Now see question number 2. I'll say quickly. Question is whether, see, A and D are given and you are asked to find out the arithmetic progression. That is simple only. A plus D, A plus 2D, or go on adding D to A, you will get the arithmetic progression. Say for example, first one is A is equal to 10 and D is equal to 10. So first term 10, second term 10 plus 10, 20, again 20 plus 10, 30, again 10 plus 10, 40, and it will go on. This is the arithmetic progression. Or second one, say minus 2, A is equal to minus 2, D is equal to 0. So minus 2 plus 0, minus 2 plus 0, minus 2 plus 0, minus 2, etc. This is the arithmetic progression. Now third one, A is equal to 4 and D is equal to minus 3. Now 4. Now 4 plus minus 3, 1. 1 plus minus 3, minus 2. Minus 2 plus minus 3, minus 5, etc. This is the AP. So whatever is A, 4, go on adding minus 3. 4 plus minus 3, 1. 1 plus minus 3, minus 2. Minus 2 plus minus 3, minus 5, etc. It will go on. Then A is equal to 1 and D is equal to 1 upon 2. See, A is equal to minus 1 and D is equal to 1 upon 2. So minus 1, add 1 upon 2, minus 1 upon 2, again add 1 upon 2, 0, add again 1 upon 2, 1 upon 2, again add 1 upon 2, 1, etc. It will go on. So like this only, last one more is there. Say A is equal to minus 1.25 and D is equal to 0.25 and minus. A is equal to minus 1.25 and D is equal to minus 0.25. So first term is minus 1.25, then add minus 0.25, so it will become minus 1.5. Again add minus 0.25, minus 1.75, minus 2, etc. It will go on. So like this we will get the AP. Now next one is again very simple only. You have to for the following APs an arithmetic progression is given and you are asked to find the first term and common difference. Say first one is, I'll do one question. Say 1 minus 1 minus 3 etc. Question is find the first term and the common difference. It is given that it is an AP. So for you will A is equal to 1. Now D is equal to, you can subtract any one term minus the preceding term. You will get common difference. I am subtracting this one. Minus 1 minus 1 is equal to minus 2. So the common difference is minus 2 only. When 1 plus minus 2 minus 1, minus 1 plus minus 2 minus 3, and it is going on. So all these questions you can check, all direct questions only. Now in the last question they are given a sequence of numbers. Then you have to check whether it is an AP or not. And if it is an AP, you have to write what is A and what is D. See, I'll do one question and I'm finishing this class, otherwise it will be too long. Say 3, 3 plus root 2, 3 plus 2 root 2, different question, 3 plus 3 root 2, etc. Question is, check whether this is an AP. If it is an AP, then say what is A and what is D. So what you have to do, second term minus first term, third term minus second term, or fourth term minus third term. In all the cases you should get the same answer. We are not going to subtract in every case. Maybe 2 cases we will check, find out, and then normally it will be an AP. Say this minus this, 3 plus root 2 minus 3. In this case directly 3 gets cancelled, we get root 2 only. Now I am going to subtract A3 minus A2, or 3 plus 2 root 2 minus 3 plus root 2. Open the bracket, 3 plus 2 root 2 minus 3 minus root 2. 3 and 3 gets cancelled. 2 root 2 minus root 2, again we will get root 2. Now if you want, you can check in this case also. If this minus this, again you will get root 2. So it is an AP. It is an arithmetic progression. And if it is an arithmetic progression, you are asked to say what is first term and what is the common difference. First term is 3 and the common difference is root 2. So simple question only, no need to discuss, you can just go through. By the time we will get an idea what will be the what is coming from this chapter, or what is there in this chapter, we will come to know. You should have a basic idea about arithmetic progression. First of all, sequence of numbers, numbers which are linked by a rule. Then arithmetic progression, in each term except the first term is obtained by adding a fixed number. Then it is an arithmetic progression. In an arithmetic progression, first term is represented by using A, and the fixed term which is added is represented by using D. Then if you know A and D, we can write the arithmetic progression. Then if an arithmetic progression is given, we can find out A and D. Then if a sequence of number is given, we can check whether it is an AP or not. So this is what we have done today. So go through the first exercise. It is simple only. You can go through. If you have problem, you can we can discuss in the next class. Okay. For the time being, this is enough. Otherwise, it will be too long. Okay. Bye. Take care.